In the last video, I had talked about how I had trained some quick and dirty models to get a sense of what the time and cost on different GPUs for different model sizes for one epoch of data, which was 4.9 million stories, which was a little over 1 billion tokens. Now that I have that understanding, before I do any more training, I want to set up my evals and the infrastructure around evals. So in this video, I'm going to talk about the next step I've taken, which is setting up eval targets and then generating completions for LLM Judge development. So first topic is eval targets. What LLM Judge score should I expect for my model sizes? This is figure 4 from the TinyStories paper, where they graciously share this data of hidden size, number of layers, eval loss, and then 5 categories of scoring. So I'm heavily referencing this to use this as a baseline as I get my own models up and running. The 4 models that I have are using these configurations. The 5 million parameter model has a hidden size of 64 and 13 layers. 25 million parameter model has a hidden size of 256 and 8 hidden layers. The 60 million has 512 and 6, and the 125 million parameter model has 768 hidden size and 8 layers. So I've highlighted those 4 on this figure 4 and just translated that data into a table. So for my 5 million, 25 million, 60 million, and 125 million models, these are the eval loss targets and LLM Judge targets for creativity, grammar, consistency, and plot. Now, 2 of the scoring categories that I'm going to quantify, which is factual knowledge and reasoning, are not included in the TinyStories paper's quantitative analysis. They do some qualitative analysis around that. So those targets will figure those out down the road. If I can get my LLM Judge to match my evaluations and to match these targets for these 4 categories, then I think it's safe to assume that when I use that LLM Judge for the other 2 categories of factual knowledge and reasoning, that it should perform pretty well. But time will tell, and it'll take some work to sort that out. So talking about this LLM Judge, no models. I don't have any data from those models. So can I make an LLM Judge? And the answer is yes. And here's my workaround. So on the left, I'm going to show the published TinyStories models on Hugging Face Hub by the authors. And on the right, I'm going to show the closest model of the ones that I'm training, or at the closest architecture of the models that I'm training. So on the left-hand side, we have the 1 million parameter model. It's actually 3.7 million parameters because they use the full vocab size as their embedding dimension, or I guess the embedding size. The key point, however, is that their hidden dimension is 64 and their intermediate dimension is 256. And that's what I'm using here, 64 and 250. My parameter count, because I have more layers, is higher, so I've chose to pick 5 million as a parameter count. But for now, I'm going to assume that the 1 million, almost 4 million parameter model, I'm going to use that as a proxy for my 5 million parameter architecture. The TinyStories 8 million has close to 20 million parameters, a hidden dimension of 256, and an intermediate dimension of 1024, which are the dimensions I'm using for my 25 million parameter. So I'm going to use the 8 million, TinyStories 8 million as a proxy for my 25 million parameter model. And the last one is TinyStories 28 million. The hidden to intermediate dimension is also, again, 4 times. So we go 512 to 2048. That's what I'm using here for my 60 million, which is actually closer to 58 million. So I don't have trained models yet of my own, but I'm using model size, hidden dimension, and intermediate dimension as the kind of proxy for developing my LLM Judge. So looking back at figure 4, I'm going to pick out the three models, hidden size and number of layers combinations, and those are going to be my targets. So when I generate stories with the 1 million or 3.7 million parameter TinyStories model, I should expect a creativity score a little less than 5, grammar score a little above 6, and so on. And these are out of 10. And then for 8 million, I have these scores, and then 28 million, I have these scores. And loss is also going to be helpful because I've found online in one location on I think it's the 33 million parameter model, where Ronan Eldon has published their recipe for training that model. And that model was trained for 20 epochs. I have 4 different architectures and 4 different model sizes. So these eval losses are going to be really helpful to just get a sense of how long I need to train these models to achieve these kinds of scores. So now that I have solved my issue with that I don't have any models, so I'm using their models as a proxy for mine, the next step is generating story completions. And for that, we're going to go into Colab, and I'm going to walk through some of the code, and this is going to be posted as a blog post as well that I'll put down in the video description below. So luckily, the TinyStories authors have published their evaluation prompts in their TinyStories dataset repo. So I downloaded those. There's 44 prompts, and this is what one of them looks like. Once upon a time, there lived a bunny in a field. Her name was Lucy. Lucy loved to have feasts and parties with her bunny friends. One day, when Lucy was about to leave for a feast at a friend's house, she realized she's starting to feel sick. She was so weak she could, and then comes the completion. So we have 44 prompts, and I think that it's large enough that there's some diversity in there, and it's small enough that I'm going to be running these eval prompts every, 500 or 1,000 steps of training. So 44 is not too bad in terms of the size. So I'm going to now walk through my code for generating story completions. Nothing really out of the ordinary here. This is kind of standard Hugging Face generation. But I wanted to point out some things that I learned when I was doing the Tiny Hackathon. And the first thing is that the tokenizer's padding size, in some cases, as it is in this case, starts out by being right, the string right. And that is problematic because when you have a batch of data, it's going to pad all of the inputs to the longest input that's in your batch. And so, for example, if I encode all of my strings, all 44, and then I pluck out the tokens for the very first string, and then I decode that, this is the text that I get. And since I've set my end of stream token to end of text to the pad token, or my pad token to the EOS token, we're seeing the EOS token here, and it's on the right-hand side of the input text. This is problematic because when I pass this to the model, it's going to generate the next token based on this end of stream token. And I found in my experiments that using this sort of padding right leads to worse generations by the model. So I think there was a Hugging Face forum post somewhere. I'll try to dig it up if I can and put it in the video description, but it talked about how the model generate call does not ignore these padding tokens, so it's important to take a look at what your padding side is. So when I set the padding side to left, I get the desired result where the padding is all happening at the very beginning, and then I'm starting my sequence here, and then it's generating the next chunk of text. Something else that, now that I'm looking at this, I should probably experiment with is using the beginning of stream token, which I'm not 100% sure. I think it's, the BOS token and the EOS token are the same for this tokenizer, so I don't think that would make a difference. So this is fine. But the positive aspect of this is that now the final token is related to could, and that's what the model is going to be doing its next token prediction with up until that point. So just a little aside on that. And if we look at our tokens, we can see 50,256, which is our padding, and then we have our actual text. Okay, so I wrapped my generation function into a little helper function that I can reuse. I always make sure to do model.eval and torch.nograd. Everything else is pretty straightforward. I have my input IDs, my attention mask. I'm setting a certain max length and min length. This is what I used in the competition, and it worked pretty well. The dataset that I had tokenized has a average story length of about 200 to 250 tokens, and I found that using a max length of 384 and min length of 120 got me close to that average, which we'll see later on. These 2 points are really important. The paper author, the TinyStories paper author, Ronan Eldon, posted also in one of the Hugging Face forums that they did temperature equals 0 and num beams equals 5. So I'm pretty sure do sample equals false is the same as temperature equals 0, but now that I'm thinking about it out loud, that's something I will check. And do sample is not 5. Do sample is false. However, when I did run this code multiple times, I was getting the same generations, so I think it's effectively the same, but I'll just double check that. Everything else is pretty straightforward. The completions, I want just the completions. I don't want the prompt because I'm storing the prompt in a separate column. And then I'm going to decode the completion tokens, and then I'm doing this as a batch. So I have 44 items in my output and 384 tokens in the output, which is the max length. And once I decode each completion, I append it to a list, and then I make sure that the length of completions is equal to the length of prompts, and I get my completions. So taking a look at some of these, again, this is a 3.7 million, right? This is their 1 million. So the 3.7 million parameter model, she was so weak, she could not sleep. She was so weak, she could, or what was it? She could, go to the hospital, or she could room. So the grammar is not great on these ones, but it's not terrible. The little boy was very sad and he didn't want to go to the hospital. That's not consistent. It's not context tracking, but that's a fine sentence. And while we're on this topic of grammar, I think something that I'm not too sure about, and I have to think through it and talk through it with Claude and check the TinyStories paper again, but my understanding of grammar is it's not just local grammar, so it's not that the sentence has to be correct, but I think they're looking at grammar across sentences. So yeah, I'll have to figure out how to define what good grammar means, and that's going to be part of my LLM Judge development process. So the rest of it is pretty straightforward. I have 3 models. I create a data frame with all my prompts and some empty values, columns for my completions. I iterate through the model names, and I download the model and tokenizer. Set the padding token as the EOS token. I generate my completions, and then I add it to the data frame. And if we look at it, at first glance, okay, these completions look different. That's good. Right? These 3 models should be completing different completions. And then I save that as a CSV. And so now I can, walk through here and do my manual evaluation for each one, take notes. Not too much annotation I can do here, but I can put comments, put my scores, maybe highlight certain examples that I want to talk about in a future blog post or video update. And then the last thing I'll do, I'll just quickly calculate the average tokens for the prompt and completions. So on average, the prompts are 62 tokens in length. On average, the 1 million parameter model, which is actually 3.7, has a output token of length of 164. The 8 million, which is closer to 20 million, is 153, and the 28 million, which is closer to 60 million, is 140. So combining the prompt and completion together, we have about a 200 to 230 average token length for the whole story, and that's about what I had. Even though I was using a different tokenizer for my hackathon, that's about what the story average was. So that looks good, right? Just a sanity check, make sure everything looks somewhat reasonable. So we can switch back to the presentation. All right, so what are my next steps? So the very next step is now I have completions for each of the 3 models for 44 prompts. So I'm going to take a sample of those. I'll probably start with, 11 or 12 prompts and prompt and completion pairs for each model. I'll evaluate the sample of prompts by hand for my 6 scoring categories. And these are my 6 categories. So I have 3 groups of categories: foundational language capabilities, emergent capabilities, and story-related capabilities. Part of what I want to do in this process of manually evaluating the data is I want to come up with good definitions of what these 6 things actually mean. So when I say grammar, what am I actually looking at? So I want to do some self-awareness as I'm grading these stories for grammar. I want to make notes on what I'm actually looking for, because those are the things that I'm going to eventually give to my LLM Judge as an instruction in the prompt. So grammar, context tracking, which is also called consistency, factual knowledge, reasoning and creativity, and plot. Now, for grammar, consistency, and plot, I do have some reference data. I have reference data in the TinyStories paper, and I also have reference data in the Tiny Hackathon because the study group leaders open sourced their eval prompts. So I have reference information there. And then I have qualitative reference for factual knowledge, reasoning, and creativity in the TinyStories paper, because they do look at a qualitative, kind of thumbs up, thumbs down evaluation of different model generations for these 3 types of prompts. But I think I'll have to do a little more work for those 3 emergent capabilities to figure out what am I actually looking for and how am I actually assessing whether a model's completion exhibits factual knowledge, or whether it exhibits reasoning, or whether it exhibits creativity. So this is really exciting. This is really getting into the weeds and kind of shaping what is meaning, essentially, and I think that's very exciting. It is a bit tedious, right? I'm going to have to do 11 prompts across 3 models, so 30 plus manual evaluations. But I think through that process, if I can find the joy, kind of lean into the joy of discovery, of figuring out what does it mean to have these capabilities, I think it'll be a very exciting process. So that's the first immediate next step. Once I get that sorted out, so once I have clear definitions of what these 6 capabilities mean, what I'm looking for, how I'm evaluating it, what I'm giving points to, what I'm taking points away for, then I'll be able to move into the next step, which is now prompting Gemini 2.5 Flash and Claude Haiku 3.5 because of their cost, and iterating on prompts until the LLM Judge scores match mine. I think I want to shoot for 90% plus of the time. So if I have 33 prompts, I want at least 30 or so of them to have a very similar score as my manual evaluation. I'm going to be using the TinyStories rubric, so they score out of 10, and there's 6 categories, so a total score that a model can have is 60. And yeah, this part will be another kind of set of being methodical, being slow, and taking time and understanding what the difference is between the LLM Judge and my manual evaluation. If it doesn't work, I have a feeling it's going to work, but if it doesn't work, I'll have to consider moving up a model class and using Sonnet. But I have a feeling that these 2 are going to be sufficient enough, but we'll see. And then zooming out and always keeping in mind what is the end goal for this research project. And the end goal is to bridge training dynamics and model capabilities. So we have the TinyStories paper where they look at things like grammar and consistency and factual knowledge. We have the small scale proxies paper where we look at things like attention logits and training stabilities and learning rates. And my goal in this project is to connect the 2. So for training dynamics, I'm looking for logits and gradients, parameters and loss, and I'm looking at their norms, means, max, and RMS values. The 6 capabilities I'm looking at is the next step I'm going to take. So the goal in my infrastructure development is I need to plug in my LLM Judge during training so that I can observe how these training dynamics are changing every 500 or every 1,000 steps. So I get some early signal on whether a training is failing or whether a training is being successful and it's worth continuing to train more. So again, very exciting stuff. I'm really enjoying the development and unfolding of this work. So stay tuned. I'm hoping to do more videos this week. I'm kind of on a roll and I hope I can keep that going. So thank you for watching, and I will see you next time.